In this lesson, we will delve into the key aspects of the design of the double support boring fixture in Project 3, ensuring the precision of the double support boring fixture. The double support boring fixture is crucial in machining as its precision directly affects the quality of the workpiece. We will explore in detail the factors related to ensuring the precision of the double support boring fixture, the methods, and key points in practical applications. Additionally, we will examine the precision standards used during the acceptance of the 1A62 lathe at Shenyang First Machine Tool Plant, a case that has been upheld for 68 years, to appreciate the significance of precision assurance in machine tool manufacturing. The double support boring fixture is widely used in the field of machining, especially in situations where high precision is required for whole systems. It provides stable support for the boring bar, thereby ensuring the precision of the boring process. So, what specific aspects are involved in ensuring the precision of the double support boring fixture? First, let's understand the basic structure and working principle of the double support boring fixture. The double support boring fixture generally consists of components such as the boring fixture frame, boring sleeve, and boring bar. The boring fixture frame serves as the foundation of the entire fixture, providing a reference for the installation and positioning of the boring sleeve and other components. The boring sleeve is used to guide the boring bar, ensuring the precision of its movement. Under the guidance of the boring sleeve, the boring bar drives the tool to perform the boring operation. In ensuring the precision of the double support boring fixture, the accuracy of the boring sleeve is crucial. The internal diameter accuracy, shape accuracy, and fit accuracy with the boring bar of the boring sleeve will directly affect the precision of the boring process. For example, a deviation in the internal diameter of the boring sleeve can cause radial runout of the boring bar, thereby affecting the dimensional accuracy and the cylindricity of the hole. Generally speaking, the internal diameter tolerance of the boring sleeve should be controlled within a small range, typically plus or minus 0.005 to 0.01 mm. The shape accuracy of the boring sleeve, such as roundness and cylindricity, also needs to be strictly controlled. Typically, the roundness error should not exceed 0.02 to 0.05 millimeters, and the cylindricity error should not exceed 0.03 to 0.08 millimeters. The clearance fit between the boring sleeve and the boring bar also needs to be reasonably selected. If the clearance fit is too large, the boring bar will wobble significantly within the sleeve, affecting machining precision. If the clearance fit is too small, it will increase friction between the boring bar and the sleeve, leading to overheating, accelerated wear of the boring bar, and possibly even jamming. Typically, for sliding boring sleeves, the clearance fit is generally set at 0.01 to 0.03 millimeters. For rolling boring sleeves, the clearance fit can be slightly reduced. In addition to the precision of the boring sleeve, the accuracy of the boring fixture frame should not be overlooked. The positioning accuracy of the boring fixture frame, as well as the flatness and perpendicularity of the support surfaces, will affect the installation accuracy of the boring sleeve, thereby impacting the overall precision of the double support boring fixture. For example, a deviation in the positional accuracy of the boring sleeve installation hole on the boring fixture frame can cause a change in the axis position of the boring bar, thereby affecting the positional accuracy of the whole system. Generally, the positional accuracy tolerance of the boring sleeve installation hole on the boring fixture frame should be controlled within plus or minus 0.01 to 0.02 mm. In practical applications, to ensure the precision of the double support boring fixture, reasonable assembly and debugging are also necessary. During the assembly process, operations must be carried out strictly according to the assembly process requirements to ensure that the installation positions of all components are accurate and secure. For example, when installing the boring sleeve onto the boring fixture frame, it is essential to ensure the fit accuracy between the sleeve and the installation hole on the frame using appropriate assembly methods such as press fitting or thermal fitting. The debugging process is also a crucial step in ensuring the precision of the double support boring fixture. During debugging, it is important to check and adjust the movement accuracy of the boring bar and the fit between the boring sleeve and the boring bar. By measuring parameters such as the radial runout and axial movement of the boring bar, one can determine whether the precision of the boring fixture meets the requirements. If it is found that the precision does not meet the requirements, timely adjustments should be made, such as adjusting the position of the boring sleeve or replacing worn components. Next, we will further understand the importance of ensuring the precision of the double support boring fixture by examining the case of the precision standards used during the acceptance of the 1A62 lathe at the Shenyang No. 1 machine tool plant. The Shenyang No. 1 machine tool plant has a 68-year history, and its 1A62 lathe is subject to strict precision standards during acceptance. These precision standards cover various aspects of the lathe, including the rotational accuracy of the spindle, the straightness of the guideways, and the positioning accuracy of the tool post. During the machining process of the lathe, the double support boring fixture also plays a crucial role. For example, when machining the spindle box hole system of the lathe, a double support boring fixture is needed to ensure the precision of the whole system. Only when the precision of the double support boring fixture is guaranteed can the dimensional accuracy, positional accuracy, and shape accuracy of the spindle box hole system meet the acceptance standards of the lathe. The rapidly developing Shenyang machine tool plant, specifically the workshop for the 1A62 lathe at Shenyang No. 1 machine tool plant, is currently manufacturing various components. In actual production, ensuring the precision of the double support boring fixture also requires consideration of the impact of machining processes. Different machining processes have varying precision requirements for the double support boring fixture. For example, during rough machining, due to the larger cutting allowance and the greater cutting forces, the double support boring fixture needs to have high rigidity and stability to withstand the impact of the cutting forces. In contrast, during finish machining, the requirements for machining precision are higher, and the double support boring fixture needs to guide the boring bar more accurately to ensure the quality of the machined surface. To enhance the precision and the reliability of the double support boring fixture, some advanced technologies and methods can be employed. For example, using high-precision machining equipment and inspection instruments to manufacture and inspect components such as boring sleeves and fixture frames. Utilizing new materials and heat treatment processes to improve the wear resistance and corrosion resistance of boring sleeves and boring bars, and implementing intelligent control systems to monitor and adjust the working state of the double support boring fixture in real time. In addition, the skill level and operational standards of the operators also have a significant impact on ensuring the precision of the double support boring fixture. Operators need to be familiar with the structure and working principles of the double support boring fixture and master the correct operating methods and debugging techniques. During operation, it is essential to strictly follow the operating procedures to avoid any impact on the precision of the double support boring fixture due to improper handling. Ensuring the precision of the double support boring fixture is a systematic project that involves the precision design of components such as the boring sleeve and fixture frame, reasonable assembly and debugging, the selection of machining processes, and the skill level of the operators. Only by comprehensively considering these factors can the precision of the double support boring fixture be ensured, thereby improving the machining quality of the workpiece. In this lesson, we provided a detailed explanation on ensuring the precision of the double support boring fixture. We first explore the basic structure and working principles of the double support boring fixture, including components such as the fixture frame, boring sleeve, and boring bar. We emphasized the importance of the precision of the boring sleeve, such as the precision of the inner diameter, shape precision, and the fit precision with the boring bar. We also explained how the precision of the boring sleeve affects the boring machining precision and the corresponding precision control range. Additionally, we discussed the impact of the fixture frame's precision on the overall precision of the double support boring fixture. In terms of practical application, we introduced the key points of assembly and debugging, as well as the precision requirements of machining processes for the double support boring fixture. Finally, through the case of the precision standards during the acceptance of the 1/62 lathe at Shenyang No. 1 machine tool plant, we gained a profound understanding of the importance of ensuring the precision of the double support boring fixture in machine tool manufacturing. I hope that through this lesson, everyone can grasp the relevant knowledge and methods for ensuring the precision of the double support boring fixture, laying a solid foundation for future practical work.